Ladies and gentlemen, moving on towards the next set of panel discussion on selection of communication technologies for smart metering. And we have a moderator, Mr. C.Balasubramanya, energy expert consultant. Our first panelist, Mr. Vinod Kumar, VI, VP, IoT Revenue and Partnerships. Mr. Sandeep Jain from Landysgir, General Manager. Mr. Fabien, Chief Technology Officer from Ubiik. Mr. Ratna. Mr. Anand Bhandari, Vertical Head, Nbiot Smart Assets, Geo. I think we are good to go, and now I would request the moderator to please take it forward.
Thank you very much. Very nice of you. Okay.
You.
Yeah. Welcome to all panelists, Mr. Vinod, Mr. Ratna Garapati, Mr. Anand Bhandari, Mr. Fabien, and Mr. Sandeep Jain. Welcome to the show. And we have here, I think, a good amount of interaction with regards to the previous sessions, which I could hear actually. However, I could summarize, on the communication technology, which is playing a very important, vital role in today's environment with regards to operational applications and also with regards to the challenges which is coming up as a subject by itself. As you know, India is planning to contemplate around 250 million smart meters in its networking system. And this plan is a very huge plan. And naturally, a lot of informative systems are coming into picture with regards to the communication platform, which is undergoing tremendous technology challenges today in the environment, like, the bandwidth, the distance, the strength of communication, and so many other factors are there which are coming into picture. And as you know, the technology is also emerging into new platforms like NB-IoT, and also with regards to the technology, we have RF mesh networking, canopy networking systems. So now in this particular platform, we have a few questions, to the main panelists, which probably, we can take up these questions so that will be consolidated by you, and then you can answer these things to the audience, which will be benefiting for their own applications and then their own interactions also. So first, I think, let us talk to Mr. Sandeep Jain, who is heading Landys+gyr General Manager. In your opinion, sir, what are all the main preconditions for smart meter communication networking system? You can just take up this question and elaborate on this so that it will be useful to the engineering community. Mr. Jain.
Good morning, everybody. Thank you, Bala sir, giving me opportunity to open the session with the answers. Basically, see, when you say about communication technologies, no one solution fits all. One t-shirt size doesn't fit for all. That's what message is clear for us when we have deployed to more than 200 utilities across the world. So every utility has its own challenges and other things. So we have to be very specific about what the challenges they are looking at, requirements. But on a very high overview, when you choose a technology, the technology should run for a considerable period of time. Let's say we are seeing that we don't replace meter in India at least for 10 to 15 years. So the technology should support this considerable period of time. It should not get absolute. And the operators which are supporting this technology should be, enduring this for a long period of time. And when you are saying that this should, when communication technology is chosen, it should support the latency requirements which are required for the for the EMI system which is there, and it should be extendable also. And when I say extendable, it extends to the smart grid vision. It should not be limiting to the meters only. It should go beyond to sensors, EV system which are coming up, and the future requirements. and it should have the regulatory requirements upcoming, which are coming up. It should comply to that network also, and the total cost of ownership should be low. That's the few pillars which utility should look at the choosing the technology, and it should be easily deployable. It should not be very difficult, when you say it. The other aspect which is generalized is the interoperability. It should support multi-vendor support. It should be open standards. It should not be limited to a proprietary type of thing. So in times to come, as the more open standards come, it should embrace that type of standardization also.
Okay, very nice. Thank you so much. If there is any elaboration from others, probably I can take it up later on. Now I will go to Mr. Vinod. Sir, welcome to the show. Can you just elaborate on the selection criteria of communication technology, mainly focusing Indian discom into account?
Yes, so let us look at the initiative in total perspective, because this particular initiative will enable the smart grid, which will enable two-way exchange of information in a real time, right? Because that is the fundamental thing which we need to look at it. Yeah. So one is that communication system should be reliable, secure, and it should run for a long period of time. As my other panelists said, there is no one answer to say what is the best communication technology. So somebody should look at the demographics, the areas in which the meters are there, what kind of challenges which will come in, and also keeping in the weather conditions also, which is one of the key criteria, right? So all these will play a very important role, right? And because the speed and scale at which this particular initiative is going on, what is very critical is, as my other panelists said, interoperability and a bidirectional exchange or a bidirectional integration between the systems in the entire chain is very, very critical to achieve the operational excellence and citizen experience. So keeping in that view, then there are the cost is always there. In any decision-making process, the costs are there, whether it is a variable cost or a fixed cost. But how quickly we can enable the process of digitizing these meters with smart meters, right? So, and because the projects are also going in different scales, because somebody starting in particular state is starting with 1 lakh meters, somebody is starting with 2 crore meters. So people are adopting different strategies. So in one project, definitely we foresee more than 2-3 technologies playing a role, because the meters could be installed in underground, high-rise buildings, or the malls, or the deep parking areas. So the combination of a GPRS or RF mesh technologies will play a very important role, which I see it in a near term. And tomorrow the satellite communications will come into picture, right? So I would say that these are the important factors which will need to be taken into consideration by deciding the communication technology. I would like to hand it over to you back.
Yeah, thank you so much. Very nice of you. In fact, the question was very well answered actually by you, so that the audience can take it up in a high spirit of this actually. I welcome Mr. Anand Bhandari. Your question is in fact very important to us. Your participation is very important to us with regards to your serving geo. Can you throw more light on how the fiber optic communication, what you are adopting today, is being entertained in the Indian environment for several applications with regards to its adoptability, acceptability, challenges, and also what criteria you adopt, for this particular communication system in the smart AMI schedules? Mr. Anand Bhandari.
Yeah, thanks, Mr. Balasubramanyam. Good afternoon, everyone. Pleasure meeting you all, and thanks Sayed for having us on this panel discussion. Now, when you talk about smart metering, fiber optics is a strict no-no. You can't really have a smart metering technology or a smart meter connected to a fiber optics. That's a pure overkill, and the wiring in terms of actual installation is going to be a challenge. Plus, the actual sabotage, someone cutting the fiber and all that stuff, becomes a strict no-no for smart metering. So the best possible communication technology given the scenario today is probably NB-IoT, because NB-IoT is something that's being adopted by 4G. It's part of 5G as well, because we just don't have to look what is happening today or 2 years down the line. We're talking about a smart metering infrastructure or AMI infrastructure that's going to connect 250 million meters over next few generations. So correspondingly, we have to keep ourselves in mind. We have to keep ourselves focused on what are the next generation technologies. NB-IoT is something that's getting adopted by 5G as well. Of course, if it's successful in 4G, 5G, 6G will correspondingly adopt it. So that is one open cellular technology I believe will definitely work in these environments. We have tried NB-IoT in Northeast. We have tried NB-IoT in dense population like Delhi, and it's given fantastic results. And these are like live deployments I'm talking about. So I believe the wait for choosing the right technology is kind of over, because we also have to look at what has happened historically about 15 years from today. We've tried many technologies. Cellular technologies have happened to work consistently across the length and the breadth of the nation without additional infrastructure requirements. So from that perspective, yes, majority of the applications would definitely be part of cellular. Some of the applications, of course, where there is no network coverage areas can be on other technologies, could be satellite, could be RF. So to answer your question, fiber is a strict no-no. And I would rather recommend NB or 4G to be the next generation technologies to be adopted for smart metering.
Very good, actually. In fact, thank you for educating us, particularly with regards to the new technology platform, which is going in a very big way in the Indian environment. I will come back to you after discussing with other panelists also. Mr. Fabien, welcome to the show. In fact, I would like to invite you now to answer a few questions with regards to international scenario in the communication technology. How important, particularly, what are the main challenges you are facing in the international level? And also with regards to the communication technology adopted by you, how this particular thing is being conceived by the consumers, and in what respect it is giving services with regards to its challenges, operability, sustained stability, etc. Can you just elaborate on that, please, Mr. Fabien?
Sure, no problem. Well, thanks for having me. Maybe I'll start with a quick introduction because we are probably smaller than the other panelists. So yeah, we are Ubiik. We are a Taiwan-based company, and we are AMI vendor to Taiwan power companies that are starting to roll out AMI in 2018. So as of today, we are the largest AMI vendor in Taiwan with 700,000 meters under contract, half of them having been deployed. And in terms of communication technology, so we have elected to go primarily with weightless LPWAN technology, which is a non-cellular RF technology. It's an open standard from the weightless special interest group, Cambridge-based special interest group. And as rightly pointed out, weightless performs great in Taiwan for AMI. And we've chosen it to operate around 95% of the meters we do connect. Now, there are always challenges and geographies where it's not necessarily economically sustainable to deploy a dedicated infrastructure to connect those meters, or we have sparsely populated areas. And in those cases, we actually do complement with cellular connectivity. So we've been using CAT1 and LTE-M and NB-IoT as well. And we really do see that indeed one technology does not fit all. Now we have a good track record with wireless. The deployment in Taiwan has a particularity that the regulator has allocated a licensed band for public utilities around 840 megahertz. And we have elected to use that band. So we actually pay a license for every base station we deploy. Something that is not been made available in India, where RF technology would have to be deployed in the unlicensed bands, where the quality of service is, of course, a little more of a challenge because of more applications. But we really want to build on that experience and to provide some technology elements to the Indian AMI, because the scale of the project and the different geographies definitely will need multiple type of technologies, including definitely the RF technology like weightless. And I do agree combination with cellular as well, but we will eventually always have to combine, because a technology like weightless, which is it's a RF cellular technology, or RF mesh are private networks you will deploy. So you will always be able to achieve the SLA by deploying more base station or fixing it yourself. Relying on the cellular infrastructure, it is lower cost because the infrastructure is always there, but you may face issues with coverage in some places. So combination of technology is always a way forward. And our message is really that, yes, I think for the AMI rollout in India to be successful, really should be very open-minded on the technologies to be deployed on the communication side, especially how the AMI rollout is planned with a service provider committing to some SLA to the DISCOM. I think it's important that they have some leverage and some flexibility on choosing their connectivity option to deliver the end result and performance that is asked from them. So there will always be a combination of technology. In some places, cellular would be just great. In some places, something like weightless would be a better choice. And sometimes you will have to combine RF mesh, or depending is mountainous or it's a plain field. Even in Taiwan, which is a very small island, if you compare to the size of India, we already face pretty different challenges from some islands, some mountains, some dense urban areas. So definitely the combination of technology is important. That's really our message. So we want to bring that experience and the challenges of deploying both a private network like weightless and a public network on cellular. We've seen the challenges and benefits of each solution, and I think a combination is definitely the way forward.
Very nice, actually. Very good, actually. One message you probably know from our Indian community with regards to the international standardization protocols. To what extent you have succeeded to achieve reality in terms of operational characteristics, international scenario?
So, well, that's a very good point. So there is a push for standardization. You know, we talk and for Indian AMI there was some talk about trying to push for 6-local WISN. There is also, I think, we need to learn from history that as of today there is no large-scale AMI deployment performing at scale that is actually based exactly on those international standards. They always have some shortcomings when it comes to really performing for AMI. So you've seen large-scale deployment, the largest scale deployment of RF mesh technology, for instance, in Japan, but they are not based on international standard either. So I think the push for standardization is a good direction, but we also have to be mindful that as of today, there is no large-scale AMI based on purely international standard. It's still a lot of proprietary and customization in there to actually have the system perform to SLA. So I think you need to find a balance between pushing for standards, but also pushing for solutions that actually do work. So I think the interoperability should be focused on the aspects where it really matters to the end customer and the DISCOM. So I very much like the presentation about the common MDMS. Just to reflect on that, and just in Taiwan, how this has been structured is actually the communication protocol between the meter and the communication infrastructure is standardized. So how the NIC is connected to the meter has been standardized, which the LMS COSEM and mechanical format of that is standardized. Then the way the data is ingested by the MDMS has been standardized as well and defined by the utility Taiwan Power. Now, for the communication infrastructure, those are the two elements where you need interoperability. As far as the communication technology itself, I think it's a little bit of a long shot to try to achieve interoperability down to the device level. I don't think it's realistic at this stage, for instance, to have a communication module from one vendor connecting to a gateway from another vendor. I think that's a big challenge. It can be done with cellular, but we also know cellular will not be able to cover all the use cases for AMI. So I think it's a balance to be found on where to push for standard and where to give some flexibility so that actually we do deliver the results.
Very good, very nice actually. Sir, Sandeep Jain, sir, you have a very interesting question. I have a very interesting question for you now. In the building blocks of the advanced metering infrastructure, you know that a meter will communicate with the HES will communicate to the MDMS, and the stream is going on. So with regards to this communication pattern, what is happening, from one end to the other end. So how the integration technology has helped actually to make a system which is acceptable and also which is applicable to the conditions, especially in Indian environment. I think you can focus, you can just give some answers, especially with regards to the challenges, that is being faced in integrating, from smart meter to the head-end system through the DCU, and from head-end system to the MDMS, and then MDMS to the customer billing arrangement. The whole thing is a scenario with which, we are working on a modular concept of operational things actually. So how this communication would help, particularly with regards to the main challenges that you are facing in regards to this application. Can you just throw more light on this? Because you are heading Landys+gyr company, which is doing a wonderful job with regards to metering applications.
So if you're talking about the integration of the communication with the head system, so we are talking about the communication at the field level, right? So there are multiple challenges actually. The people, even the same meter, let's say it's a 15959 compliant, and you want to integrate with a cellular modem, which is like open to now, you will face challenge to it. We have seen that the level of integration will have certain level of inputs and modification required from the meter manufacturers also. It is true for the RF also, it is true for the cellular also. PLC, I'm just taking it away because PLC as a technology is very minuscule in India and very not apt to Indian condition. So that's one thing. Second thing, the most of the manufacturers are not coming to a service provider who are also a meter manufacturer. Let's say. So there is a like of a, I will not say the word untouchability, but then there is a reference that they don't wanted to open up with a vendor. But then this has happened in Tata Power, as I can say, multiple vendor has come. Bangladesh, the prerequisite itself in the RFP was that multiple vendors should be operability has to be ensured, whether it is shown at the time of winning the tender or not, but it has to be achieved in a time frame manner in which we have delivered to them. So these are special use cases where the interoperability at the comms level can be achieved. We have some change, and as a fraternity, we have to see that it's a large market, 200, 250. So it's a large one, and no one player will be able to suffice the thing. So there is a when we have a standardization at certain levels, all the manufacturers will have certain level of percentage to them. So there is no dearth of business in it.
Exactly.
And then when you have a scalability there and you have multiple vendors coming into place, the cost also will down. Exactly. It will benefit the end consumer, utility, service provider, whoever it gives. There will be no challenges in manufacturing also, no bottleneck. We can have our own setups. So supply chain, as you see in the COVID situation, if we have a large number of vendors which are going on interoperability, and simultaneously we can have large deployment. We have in India. It's a very open truth that the supply chain is hitting hard, and we are not able to suffice to the utilities needs in large number. If that happens, then our back channel, back supply chain, everything will be streamlined. That type of integration. If you talk about HES and MDM, yes, this has been mostly done up with SIM2, multi-speak. Then there are RESTful APIs. So this type of communication is seamless. And as the system requires validated data, the enterprise level applications and other things should look at the MDMS as the part, bearing one or two applications which is real-time data streaming from the HES and alarms and other things. The other things should connect to the MDMS. I was part of the, I just attended the last few minutes of the common MDMS solution by EasySoft. I'm really appreciative of the solution that you have different look and feel, different interaction. It's better to have a common MDMS. That's
Very good, actually. Very nice. Sir, Vinod sir, there is a question for you. Can you elaborate more on LoRa technology and NB-IoT technology with regards to Indian environment?
Yeah. So I'm not a very expert on LoRa and NB-IoT. My colleague Anand, who is there on the panelist, can more talk about it. But we know, see, the LoRa part and NB-IoT, they have their own set of challenges and they work in certain environment and certain conditions, right? So because you need to, you cannot have just that infrastructure only for this particular use case to get the advantage and the cost benefit analysis, right? So somebody, that adoption has to be much larger is what one of the, because look at it how you, if you have to set up LoRa or NB-IoT only for this, then it becomes very costly affair. So it will be a non-starter. As I said earlier, somebody has to look at what infrastructure is available in a location where you are doing the smart meter installation, and then decide whether it is LoRa, NB-IoT, or mesh or cellular, right? So yes, definitely those technologies may give you lesser variable cost over a period of time, but whether your capex investments are in place. So those are the things which needs to come in, and also the meter capabilities, because the standardization and the testing. So all these things also will play into a role. And tomorrow the satellite communications can come and change the game completely, where it could be much cheaper than NB-IoT or LoRa, or hit the remote areas much quicker, right? So I would not say it is a challenge. I would say more to look at more of a pointed solution where this particular infrastructure is there which can be leveraged. That's how I look at it.
Okay, very nice, very nice. I request Mr. Anand Bhandari to answer my question. This is with regards to the 4G platform where we are in India. As it stands, we are in 4G and moving slowly to 5G level. And internationally, as I have gone through the latest papers, they are going even for 6G in Nokia Bell Laboratory. So with this rapid change and obsolescence in the technology observations, whatever we have, what is your thinking mechanism in terms of infrastructural change, in terms of managing the whole show for suiting these new platforms for communication technology? Can you throw more light, Mr. Anand Bhandari, sir?
Sure, Mr. Bala. So I'll just take a minute to answer Vinod's question on LoRa versus this thing.
Welcome. Very nice. I look forward to it. Yeah, please.
So the primary difference between LoRa and the cellular technologies is about the firmware upgrades. And that's one of the most critical aspects where LoRa is not able to support the FOTA part of it in toto. So that's where LoRa has, I mean, you will not see LoRa as an adopted standard for smart metering. Yes, it is good for general applications for sensors, environment monitoring, and so on and so forth. But wherever you have these firmware upgrades, it is not yet proven to the extent it should have been. Now, coming to the second part of the question, which was infrastructure for 4G, 5G, 6G adopting technologies. Yes, now when we talk about 4G or narrowband, both of them, they use same infrastructure. So you don't really have to invest anything else. If you have 4G, you automatically have narrowband or Cat1 or whichever LTE communication technologies are as per release 13. So that's one part. It really works flawlessly. The second part is whether these technologies are going to get adopted in 5G, 6G. So the answer is yes. You should pick up a technology which is future looking, which is going to be adopted. Now what happens is, I'll give you a small example. When we talk about cellular technologies, the problem often is whether a tower can handle a load in terms of the consumer data, the consumer mobile phones, as well as these appliances. That is an advantage usually RF has, because RF would talk about dedicated network for metering. Now, when you come back to the cellular technologies, usually you would go with a TCP IP protocol or IP protocol, then a TCP DLMS over it, and one data sending would usually take about 4 to 5 transactions. Now, that amount of time, the air time that Mter uses is way too high when you talk about this technology, when you talk about IP-based technologies. What you should do is improvise on the best of both the worlds. Now, what I mean by best of both the worlds is, can you have narrowband IoT or any of the cellular technologies talking like RF? So the answer is yes. There is something called as NIDD, non-IP data delivery. It works exactly like RF, just that the network is already there. So probably, if I can talk from the perspective of Geo has around 300,000 plus towers across the nation who are already radiating narrowband IoT. So it's like, zero infrastructure cost for a meter utility. You just go plug and play and start sending the data. We've seen results in the first test itself in a crowded place like Delhi going about 98%. In Meghalaya, they are about 95% plus. So the kind of response or the performance feedback is way too good even before we have optimized the technologies and during the initial phases. So we should be looking from a perspective of what is available today and what is available tomorrow. Right now, our primary focus always is which is a connectivity technology, how you deliver connectivity. The question should be, how do you deliver data? And if you can crack that piece of delivering data from the meter to the cloud reliably, we are done. So we should be focusing more on data as a service rather than connectivity as a service. So you combine head-end system with a narrowband IoT technology, you provide that as a package to the utility. The utility has a single throat to choke. It doesn't really have to go to, "Arey bhai, Jio aapka network nahi hai, head-end system ka ye problem nahi." So all those issues are literally taken care if you provide data as a service and with a technology which is obviously future-looking, which I strongly believe narrowband is and is going to have a positive impact, not just today, but 10 years down the line, 15 years down the line.
Very good, actually. Okay. Thank you so much. Now I think Mr. Fabien, you can just elaborate mainly, on the RF mesh technology is going on in a very big way. Okay. Canopy-based technology is also going in a very big way. Lot of technologies are coming into picture today. And of course, the user is under confusion. Which particular technology is to be selected for which particular application with special regards to AMI systems. So what is your point on this particular selection criteria? And how, see, for example, today Zigbee is there in home area network, Z-Wave is there in home area network. Okay, in neighborhood area network, we have the complex hybrid versions. Okay, so like that, we have ample technology scenario which is coming up and it is getting confused actually. Can you throw more light on how to streamline this operation and to focus on which particular technology is applicable for the situational aspect, which is taking into account several factors, like adaptability, acceptability, and also the usability of these things, and taking into account even criteria of, stability and sustainability. So can you just throw some more light on this so that it will be useful to the panel?
Sure. I'll be happy to. So first, I will actually make one statement that we sometimes oppose kind of like cellular technologies and RF mesh. So I just want to actually rather mention that because the main difference in the end between cellular technologies and those RF technologies that do not have to be mesh, by the way, right? So weightless, for instance, is a star topology, very much like a cellular network. But the main difference there is actually one is operating in a licensed spectrum. So Geo, for instance, has a licensed spectrum where they can control the quality of service. Whereas technology like weightless, RF mesh, or Lora that you mentioned just before are operating in unlicensed spectrum. So that's a spectrum that is essentially free to be used, but is limited in availability, like 3 megahertz in India and soon to be increased, but it's still a limited spectrum to be used. And it is to be shared across multiple applications and vendors. So I think that's actually the main difference between cellular and RF technologies that are deploying unlicensed spectrum. Now, of course, the advantage of deploying in those unlicensed spectrum is that you do have the ability to extend the network or deploy the infrastructure exactly where you need it. So you can always cover when you have a gap of connectivities. Now, to achieve that, there are different topologies of network, right? So, cellular or wireless use a star topology. So it's really base station. The devices communicate to one base station. They are authenticated with one base station in the network. There are approaches where you use a mesh type of topology. The drawback of mesh technology is that usually you will be repeating the data. So in terms of overall spectral efficiency, how much data you can carry per megahertz of spectrum will be lower, but it has some benefits when you cannot necessarily install a base station in the proximity of the device. So sometimes having some level of hopping and going through a device could be useful. But I will not say that should be the mainstream way to go. And we see cellular is not a mesh technology, and it does perform reasonably well. To take up on what was explained before, yes, we've seen NB-IoT. We have to keep in mind indeed that it's operating in a licensed spectrum and is dedicating a very small portion of the spectrum, like typically 180 kilohertz, to those NB-IoT applications. So what we have to keep in mind is that the capacity that is offered by NB-IoT is fairly limited. It's not originally designed for electricity metering, but more for water, gas, sensors that will transmit 1 to 10 times a day. So electricity metering on NB-IoT is always going to be a challenge on capacity. But we do see that as a good complementary solution. I would see that as a challenge to deploy a large-scale network of electricity meter purely on NB-IoT, but combining with RF could be the best way forward. So I think the main difference is whether it's a licensed spectrum or unlicensed spectrum, because essentially it means relying on a private deployment where you deploy the infrastructure as needed, or you rely on an existing infrastructure. And of course, the existing infrastructure has this cost because the spectrum has some cost, but it has the benefit of being already there. As you mentioned, 300,000 base stations already broadcasting NB-IoT. Whether that's enough in terms of capacity, spectrum capacity to deal with all of AMI across India is still a very big question mark. And we've seen around the world that typically would be combining LTE plus NB-IoT, like LTM plus NB-IoT. So only the devices that are out of reach of the normal LTE will fall back to NB-IoT. And that's very much what we do with wireless. So, and yeah, so to your point on Zigbee, so, I mean, those technologies are for shorter range type of network. So for AMI, the amount of data is not large, but it's not small either. So you do need technologies that have good spectral efficiency, which make decent use of the spectrum. And for instance, you were talking about Lora. Lora is achieving great range, but the drawback of Lora is that it's using a lot of spectrum to do so. So actually, when you want bidirectional communication with a decent amount of data transferred both ways, it's using too much spectrum. And given the unlicensed spectrum availability in India, this makes it very challenging, if not possible at all, to deploy for AMI. So I think those are the differences to keep in mind. There is again there is no one technology fits all. We do not have to oppose mesh or star topology either, because in the end, some would say that mesh has this, it can adapt when there's a failure of a node, but it's true as well of cellular or wireless technology. Normally a device will have many base stations in range. So if one fails, it will always find another one to connect to. So it's not as simple as that. So I think at the end of the day, like the DISCOM, the end customer should not care that much about what technology is used. As I mentioned, it should be to the service provider, work with its partners to make the good mix of technology for different geographies or location. A dense urban city like Delhi or the mountains of the Northeast would be different, and different technology would work. So it's not a one size fits all. But we've seen the challenge of cellular and also the concern that, if you rely purely on public infrastructure, what do you do for those meters that do not connect, right? That's a challenge to fill those gaps. There are solutions for that, but I think a combination of technology is always the way forward. But in the end, wireless communication is always about efficiency of usage of the spectrum. No matter it's licensed or not licensed, the spectrum is not a free resource anyway. So you need to use it in a good way. And that's what we try to achieve with wireless as well, which is a narrowband technology, which you could summarize it as a simple Nbiot in unlicensed band. And that's an open standard as well. So a combination of both will always be the way forward, and even some fallback on LTE. And just one point about where I would agree is for future-looking technology. I mean, you still have to look back at how long 2G has been sustained. It's been a long time running. So of course now we're talking about shutdown, but look at 30 years of 2G being run. And I think LTE-M and maybe to some extent Nbiot, they are under the 5G umbrella, so you can connect it to a 5G core. And fundamentally, those are good technologies. So I do see those 4G, LTE-M and Nbiot technologies still going forward for years to come. Yes, people talk about 5G, 6G, but that's typically to operate in higher bandwidth, higher spectrum. I think the lower spectrum will still be using LTE-M and Nbiot 10, 15 years from now. So I will not be so concerned on that aspect. But of course, operator may not commit to that time. But I would say that LTE-M and Nbiot are the new 2G. So I would expect a long life for those two categories of technology specifically. In the bands we're talking about, 800 megahertz, 900 megahertz, it's not going to shift to 6G anytime soon. We took 25 years away at least, right? So I would not be so worried on that aspect. It's true, it's a concern, but it's not moving as fast as we say. 2G has been there for a long time. 3G was not a very suitable technology for IoT or AMI anyway, so it has been short-lived. But I think 4G will be there to stay, and especially the IoT part of 5G, which has no replacement in 5G. LTE-M or Nbiot do not have any equivalent in 5G. They will carry on in 5G. So on that, I will actually agree with what has been said before. I think I will not be so worried about that. There is question on performance and capacity that could be addressed by complementing the technology, but for the lifetime, I would be fairly confident.
Very good, actually, very nice. Mr. Vinod, can I ask you a question, sir? With regards to the licensed and unlicensed spectrum of communication, which is causing a concern today. That is number one. Number two, is there any health hazards with regards to this communication, especially with reference to the smart metering and AMI applications? Just two questions. You can answer these two, then we'll wind up the show.
Yeah, as the other panelists said, right, it is not about whether it is licensed spectrum or unlicensed spectrum, right? It is about the right service, which is very, very critical for the operations to run smoothly, right? Because ultimately why we are doing this is to enable the smart grid infrastructure available in the country so that the citizens get the best of the services, and also transform and cut the distribution losses and transform the entire distribution and transmission business, right? I think that is the point number one, which we need to take in, because whether it is licensed or unlicensed, it is at the end of the day, it is a total TCO which somebody should look at it, right? And there are technologies which, like RF don't require any licensed spectrum, right? But I think what important point which I would like to bring upon is everybody has to choose the technology based on the technology which they choose, has to also take care of certain things, because every alternative has its own advantages and disadvantages. So it is important, how do you reduce the disadvantages or eliminate the risks which by choosing a certain technology, right? So which I will come upon. And the other part from the health hazard perspective, see, these are nothing new technologies which are adopted anywhere. We are using the mobiles for last 2 decades. So even though there are certain reports which are there, but nowhere it has become a hazard or a health hazard which is there, because your telecom network is in the same place, your radio frequency radios which we are using. So there is something which we have brought in, something which is new and untested. So people should not be worried about health risk related aspect. Because see, based on our experience, both in India and globally, right? If somebody is choosing the cellular technologies as a medium, right? So we found doing certain basic things will reduce the complexity. For example, the testing the meters with the communication vendor, using the right SIM, like using the robust plastic SIM, which will operate in all weather conditions, right? And also having the callback facility with IPv6, SMS to manage remote connection and disconnection, and integration between HES and an MS system, right? Will reduce a lot of challenges which people see today in this particular business. That is what we are focusing. So with our experience, we have built the best practices, okay, across all the 3 stages of the project, during the planning stage, to the installation stage, and the operation stage. So what we are focusing today is the lineage which you can identify on the problem is very critical. Today, that is what we want to focus on. How can you have a lineage and resolve the problem and do an RC in the quickest possible time? So I think that is where the focus should be, not to worry about whether it is licensed or unlicensed, right? Right. And there are, because one of the panelists raised an important point where they said it is different vendors are playing a different role. So there I want to bring up a point that telecom providers are in a best position to offer the ICT solution for the project. Irrespective of the HES system, MDM system which you choose, the telecom player can offer connectivity cloud and integrate with HES and MDM systems as part of one service, because we are also used to serve such a large customer base. If you're talking about 25 million customers, like we itself is managing 25 million customers, right? So when you look at a large scale, I think there is a safe where it comes to a consolidation where a single player can make a big difference, at least in ICT technology. That's what I want to see. So people should look at those. That's where I want to sign it off. Yeah. Thanks for the.
It's very nice, actually, very nice. So last question to Mr. Sandeep Jain, with regards to, with all these hearings, whatever we have made him, what all the questions, we have raised actually. Which is the best technology which you suggest for the Indian environment?
Very difficult question. Anyway, before I answer that question, I will just add on to Mr. Vinod's statement. See, license, unlicensed, rightly he said, he doesn't care about it. At the end of the game is the data should come to the system and it should pass on to the relevant systems as per their needs, the velocity it needs. Let's say outage. Outage happens, it should be immediately transmitted to the system. So SLAs are more important. SLAs not at the BTS level, not at the HES level, not at the MDM level. It is at the endpoint level, which is required. Yeah. So you can't, we are as a partner, we don't differentiate between the service provider. We do a solution end to end. We can't leave a security at meter level only. It has to be end to end. We can't leave the data to be at the level of DC only, because okay, my level is I provide meter, comms, and the network, and the backhaul is provided by telecom service provider. So we can't leave that. So that's point is one of the major things which is there. Now coming to the complex situation, and so everybody we started that one T-set size doesn't fit all. That's one. But anyway, coming back to your answers, I will try to answer that question. See, first we have to go to the bottom of it. The use cases of the utility will determine which technology you want to use. Feeder metering may have certain different utilization. The residential segment will have another things. Believe me, there are many other factors which we don't even foresee today also will come into place. But what we see is that, let's say the density where it is there, how much density you have. You can't, I've seen in one of the Asian country, the endpoint density is 1 square kilometer has 10,000 endpoints. Believe me, if you put everyone on one technology, like the public network or a shared network on cellular, it won't work. So we have to divide somewhere where it goes in a RF mesh technology, you pull up there. If you wanted to segregate the strategies to deploy a AMI also will depend. Let's say a utility decides only DT metering has to be done first because they don't have the money out of it. So there are a lot of aspects, the financial side, the operational efficiency, the business goals they want to achieve, the strategies to deploy it will different. Let's say a utility wants to have the same platform with distribution automation, then the strategies will be different. So no one perfect answers, but then it gives you a glimpse at how does it, you have to choose it. So it has financial, business, operational, but the bottom line is the use cases of the utility. That will determine how do you do it.
Okay. So thank you. If there is no other question, probably, I think we can hand over the mic to Mr. Aayera. Thank you for the opportunity given. I thank Mr. Fabien, Mr. Vinod, Mr. Anand Bhandari, Mr. Sandeep Jain for having joined me in answering several questions and clarifying the whole thing. It was a very nice interaction I had actually. And I would now hand over the mic to Aayera for further actions. Okay. Thank you so much. Very nice of you.
Thank you, everybody. It was really, really informative. And we're looking forward to start the next session at 2 o'clock. So now we break for lunch and networking. Thank you so much. Have a good time.
Thank you so much.
Thank
Very
you.
nice.
Thank you.
Thank you.
Bala sir, you're a good moderator. Thank you.
Thank you so much, sir. Very nice of you. Very nice of you. Thank you so much. Let us keep in touch, sir.
Yes, sure. Good day, sir.
Thank you, Mr. Fabien. Let us keep in touch.
Thank you. Yes, thank you for the opportunity.
Thank you, sir.
Bye-bye.
Thank you. Very nice of you, sir.
Thank you.
Good day.